Armando Hasurungan, Biology and Medicine videos. Please make sure to subscribe, join the forum and group for the latest videos. Please visit Facebook Armando Hasurungan. In this video, we're going to talk about blood gases. So gases in the blood, specifically focusing on oxygen and carbon dioxide. So we're actually looking at the concentrations of these gases in our lungs, the blood, and the tissues. And what I mean by concentration is actually the partial pressure. The higher the partial pressure of a gas in an area technically means the higher the amount of that gas in that area. So to begin, we first must look at the partial pressure of oxygen in the atmosphere. So we have a significantly actually higher partial pressure of oxygen than carbon dioxide in the atmosphere. To be correct, the partial pressure of oxygen is about 160 millimeters mercury, and the partial pressure of carbon dioxide is 0.3 millimeters mercury. And so this is what we actually breathe in during inspiration. What we breathe out is a partial pressure of oxygen of about 120 millimeters mercury, and a partial pressure of carbon dioxide of about 27 millimeters mercury. So these figures, they tell us two important things. First is that we don't use that much oxygen, so we don't use up all the oxygen we breathe in. The second thing is that we only produce a little bit of carbon dioxide. But why then is there such a low partial pressure of carbon dioxide in the atmosphere? Well, this is because the plants around us, they use the carbon dioxide, and together with water and sunlight, they can produce energy. And as a byproduct, they produce oxygen. And so this cycle continues. We will breathe in this oxygen, and we will produce the carbon dioxide, which will then be used by the plants, etc., etc. So let's have a closer look at gas exchange in the lungs. When we breathe in these gases, the gases will travel down our respiratory tract to the terminals called the alveoli. And here I am drawing three alveolar sacs. The pulmonary arteries come towards the alveoli, carrying with it deoxygenated blood. And then they will leave the alveoli with reoxygenated blood through the pulmonary veins. And this all is thanks to the gas exchange process that occurs within the alveoli. So let's have a look at this gas exchange process in a bit more detail. So here we are looking at an alveolus. Here is the pulmonary artery carrying with it deoxygenated blood, and then we have the pulmonary vein, which has been reoxygenated by the alveolus, and the pulmonary vein returns back to the heart. So the principal thing here is that we breathe in oxygen, which comes down to the alveoli, and we breathe out carbon dioxide. Of course, in reality, we also breathe in carbon dioxide, and we actually breathe out a lot more oxygen, if you remember. The partial pressure of oxygen in the alveoli is higher than carbon dioxide. The partial pressure of oxygen in the alveoli is about 100 millimeters mercury, and the partial pressure of carbon dioxide is about 40 millimeters mercury. There's actually a slightly higher partial pressure of oxygen in the alveoli. It's like 105 or something, but 100, just remember 100. Anyway, so this is the partial pressure that exchanges with the atmosphere during inspiration and expiration. Now, as I mentioned, the heart, or if I didn't mention, I'm mentioning it now, but the heart, it will pump deoxygenated blood to the lungs through the pulmonary artery. Now, the pulmonary artery has a slightly higher partial pressure of carbon dioxide than oxygen. So the partial pressure of oxygen is actually about 40 millimeters mercury, and the partial pressure of carbon dioxide is about 46 millimeters mercury. So the carbon dioxide will move from an area of higher concentration, higher partial pressure, to an area of lower concentration, lower partial pressure. So carbon dioxide will move from the blood into the lungs, into the alveoli. And oxygen will move from an area of higher concentration to an area of lower concentration. So the oxygen will move from the lungs, from the alveoli, into the blood. And this is how the deoxygenated blood supply becomes reoxygenated. So the new partial pressure in this reoxygenated blood is oxygen of about 100 millimeters mercury, and the partial pressure of carbon dioxide, which is now 40 millimeters mercury. So there is a higher partial pressure of oxygen than there is carbon dioxide. This blood vessel is known as the pulmonary vein and will carry this oxygenated blood back to the heart. The heart will then pump this oxygenated blood to the tissues through the systemic arteries. Remember, this blood is rich in oxygen. The partial pressure of oxygen is much higher than that of carbon dioxide. And just recapping, the partial pressure of oxygen is about 100 millimeters mercury, and the carbon dioxide is about 40 millimeters mercury. The tissues, on the other hand, has a slightly lower partial pressure of oxygen compared to the partial pressure of carbon dioxide. The partial pressure of oxygen is less than 40 millimeters mercury in the tissues, and the partial pressure of carbon dioxide is greater than 45 millimeters mercury here. And remember that gas, they move from an area of higher concentration, higher partial pressure, to an area of lower concentration, lower partial pressure. So as a result, oxygen will move from the blood into the tissues. The tissues will use the oxygen and create carbon dioxide as a byproduct. And then the carbon dioxide will move from the tissues into the blood. So now the blood is deoxygenated because the oxygen has been used by the tissues. This new deoxygenated blood supply has a partial pressure of oxygen of about 40 millimeters mercury and a partial pressure of carbon dioxide of about 46 millimeters mercury. This deoxygenated blood are the systemic veins and will return to the heart. The heart will then pump this deoxygenated blood supply to the lungs through the pulmonary arteries. And then the cycle continues. This deoxygenated blood supply will be reoxygenated, and then the cycle continues, etc., etc. We can actually take blood out from the artery and measure the arterial blood gas. Arterial blood gas analysis is used to measure the pH and the partial pressure of oxygen and carbon dioxide in arterial blood. It can tell us if our body is suffering from acidosis or alkalosis, and whether it is a problem of respiration or kidneys, for example. So let's take a quick look. Arterial blood gas can measure, can tell us if our blood is acidic or basic. So normally the pH is between 7.35 and 7.45 in arterial blood. Changes in these figures can result in acidosis or alkalosis. Arterial blood gas can also tell us the partial pressure of oxygen, which is normally 80 to 100 millimeters mercury. If it's below 80, this will tell us that it's cyanosis, that we have cyanosis. A partial pressure, the arterial blood gas can also tell us the partial pressure of carbon dioxide, which is normally between 35 and 45 millimeters mercury. Changes in these figures can indicate possible respiratory acidosis or alkalosis. Then you have this other ion called bicarbonate, HCO3-, which is normally 22 to 26 I think it's milli equivalent per liter. It's just remember 22 to 26. And changes in these figures can indicate metabolic acidosis or alkalosis. But obviously you have to use all these readings together to formulate a proper cause of acidosis or alkalosis. And just an important note to make: the saturation of hemoglobin with oxygen in the arterial blood gas is about 98%. So the hemoglobin is saturated in oxygen. But we can also measure the venous blood, so the mixed venous blood. So obviously the venous blood is going to be different to the arterial blood in the acid-base readings. So in the venous blood, the normal pH range is between 7.38 to 7.43. So it's slightly more acidic, I think. And this is because we have more carbon dioxide. The partial pressure of oxygen is between 35 to 40 millimeters mercury, and this is quite normal because we've used up oxygen by the tissues. The partial pressure of carbon dioxide in the venous blood analysis is between 41 to 52 millimeters mercury, and this is normal as well because we have an increase in carbon dioxide. And the bicarbonate levels is between 24 to 28. And this is because bicarbonate will try to neutralize the acidity due to the carbon dioxide. And an important thing to note is the saturation of hemoglobin in venous blood is about 75%. And this is because oxygen has been used up by the tissues again. So just to quickly end it, this venous blood will then travel back to the heart where it will be pumped to the lungs. And then this blood will be reoxygenated, the carbon dioxide will be exhaled out and into the atmosphere, and the carbon dioxide will then be used by the plants, and then the cycle continues. So I hope you enjoyed this video on blood gases and an introduction to arterial blood gas analysis. Thank you for watching. Bye.